In this, we will compare the dot product with the cross product. So there is a comparison between these two products. In scalar product, the result of a dot product is a scalar quantity. It gives only the magnitude, while the cross product is a vector quantity. It gives the direction. So direction vector is always there in the cross product. Dot product follows commutative law, while the cross product does not. A dot product of vectors in the same direction is a maximum, while the cross product of vectors in same direction is zero. Dot product of orthogonal vectors is zero, while the cross product of orthogonal vector is maximum. Dot product does not follow the right hand system, while the cross product follows the right hand system. It always defines through right hand system. Dot product is used to find the projection of vectors, while cross product is used to find a third vector. Dot product represented by a dot and cross product is represented by the cross. While associative law also hold in dot product, but it does not hold in the cross product. You can add one more comparison in it. We have a determinant formula. This easiest way to find out the cross product of two vectors. We have a determinant formula in which we write the direction vectors in the first row and the components of a vector in the second row, and the components of the second vector in the third row. So expand with the help of first row I cap. We are left with A2, A3, B2, B3 mod minus J, A1, A3, B1, B3 mod plus K cap, A1, A2, B1, B2. Taking their determinant, we are left with A2, B3 minus B2, A3, I cap minus whole bracket B3, A1 minus A3, B1, J cap plus A1, B2 minus B1, A2 bracket close K cap, which gives actually A cross B. Now taking the cross product of two vectors which are in the component form A cross B, direct we can write it by using the method of determinant. We substitute their values and we are left with the same answer as we have done in determinant of by using the method of determinant for solving A cross B. ठीक है, और इसी तरह अगर हमारे पास मोर देन टू वेक्टर्स हो उनको भी उसी तरह डिटर्मिनेंट से हम लोग सॉल्व कर सकते हैं और फाइंड आउट कर सकते हैं कि व्हाट विल बी द A cross B cross C or vectors more than that. There are some practice examples. You have to find out A cross B and you are given with different values of vector A and B, either in the form of components or in a triplet set. So you have to find out A cross B. You can use any method by using it by solving A cross B by using the method of determinant or by using the method of components. All up to you how you can find it out. Now we have the applications of cross product in our daily or real life. Finding moments, finding dogs, rowing a boat. It's also an example of a cross product, finding the most effective path. Similarly, finding out the areas in volumes. These are also the examples of the cross products. Another example of A cross B is you can find out the area, and the magnitude of A cross B is the area of parallelogram with sides A and B. As you can see that if you can extend A vector in the same parallel direction and B vector in the same parallel vertical direction, you can find or obtain a parallelogram. So the magnitude of A cross B is actually A magnitude, B magnitude, sine theta. which gives you the area of a parallelogram with sides A and B, as A is the length and B is the width, right? You can see in the figure. Similarly, we have another example. Cross product gives the volume of the parallelepiped. As you can see that if you have three vectors which are denoted here with the blue lines, the vector A, B, and C, and then if you can extend these three vectors, you can get a parallel piped with the sides A, B, and C, and their dot and their volume is given by taking the magnitude of their scalar triple product, which is equivalent to A dot B cross C. While first of all you have to take B cross C, then apply the dot product on their answer. As you can see that the scalar triple product is given by A vector in three coordinate axes A1, A2, A3 dot B cross C. The value of B cross C you all have already find it out. Put just their answer. So taking the dot product with these values, we are actually having the determinant of these three vectors a1, a2, a3, b1, b2, b3, c1, c2, c3, which is uh, if you want to find out a scalar triple product, we simply take the determinant of these three vectors. Now we have an example in which we are given with three vectors and we have to find out the volume of a parallelepiped. Now the volume of parallelepiped is given by A dot B cross C, which is actually equivalent to the determinant of these three vectors. Now substituting the values of these three vectors in the determinant, in the first row we have all the components of A, in second row we have all the components of B, and in third row we have all the components of the third vector. Now expanding with the help of first row, so we are left with a 6 into determinant of 1, 2, minus 2, 5, which will give you the answer 9, and now minus 3. Similarly, we are left with 0 to 4, 5 mod. So, in the third, we are given with minus 1, and the determinant becomes 0, 1, 4, minus 2. After solving their determinants in determinants of 2 by 2 matrix, we are left with 54 plus 24 plus 4, which gives you 82. Another practice exercise in which we are given with the vectors u and v, and we have to find out their cross products. So apply the formula and find out their cross product as the components of these vectors are given, and find out the right answer. We have another example in which we have to find out the cross product of u and v. So, or also we have to show that u cross v is orthogonal to both u and v. So we will check that they are perpendicular. U cross v is perpendicular to u, and also it is perpendicular to v. And how we check the orthogonality? By taking their dot product. So firstly, we have to find out u cross v. U cross v can be find out by using the method of determinant. So the vector A, the components of vector A in the second row, and the vector components of vector B in the third row is now expanding, and the determinant we are left with minus 10 I cap minus 10 J cap plus 25 K cap. Now we are left with the triplet set minus 10 minus 10 minus 25. That shows the cross components of the cross product U cross V. Now we will show that U cross V is orthogonal to both U and V. We find the dot product of U cross V with U and U cross V with V respectively. Now firstly we will find the dot product of U cross V with U. We got 0. That shows that U cross V is perpendicular to U, or we can say that these two vectors are orthogonal. As you can see that their answer is equal to 0. And if the dot product of two vectors equal to 0, then these two vectors said to be orthogonal. So the vectors U cross V dot U are orthogonal vectors. Now we will check the orthogonality between the U cross V and we substitute the value of U cross V and the value of vector V, and after applying the operation of dot on these two vectors we got 0. So that shows that U cross V is also orthogonal to the vector V. Hence, both dot products are 0. The vectors are orthogonal. The vectors U cross V are orthogonal. The vectors U cross V is orthogonal to both vectors U and V. As you can see, and you can take different vectors and check their orthogonality in this way. We have another example for the practice. Find the area of a parallelogram with adjacent side U and V. The vectors are given, so the area of parallelogram is given by the cross product of two vectors. So taking their cross product by using the method of any method you can obtain to solve these questions. In this example, I have used the method of determinant. Taking the cross product, substituting the values of u vector and v vectors, and expanding with the first row. In the step 1 we are done with the cross product of u cross v. Now in the second step, in order to find out the area of a parallelogram, we have to find out the magnitude of u cross v. So how can we find the magnitude of u cross v? It is given by square root of square of first component plus square of second component plus square of third component. That gives the value 1217, or about 34.9. Another practice question. Find the area of a parallelogram with sides if with sides are given. So you have to find out the area, and in order to find out the area of a parallelogram you have to follow the two steps. Step number 1 is you have to find out u cross v, and then you have to take its magnitude, which gives you actually the area of a parallelogram. So after doing these two steps you will find out the exact or the appropriate answer. There are 4 answers, so after solving the question you will get to know which is the suitable exam answer for the question.